Hey gang. Hey gang, sorry, I guess we might have some mix-ups. We are meeting Monday and Wednesday physically in the classroom. So I'm just going to do a quick review of what we covered on Monday. So we didn't cover anything about the chapter, just I like to do like a little intro to what is networking. So we started out just kind of talking about what are some of the different parts that make up a network. So like an example, we said like switch. So that would be, a network switch that's, a rectangular box. Or AK, something like this. And then we talked about PCs. So that could be Mac, Windows, smart thermostats, things like that. And then it takes an IP address. We talked about printers. So not talking about how they function or anything, but just talking about what are some of the items that we would find on a network. Cabling. So cables. And I didn't spell that right, so pardon me. So we call that, in cables, we call that Cat 5, Cat 3, 6, 7, all the way up to 9. It just basically just dictates how much, what kind of speeds you can run through. So here's a little thing that we should know is 100 meters is how long, or 329 feet is the length of the cable can run. We talked about, let's see, we just trying to remember in my head. So we talked about PC, switches, printers, routers. Again, if you're not familiar with a router, this is an example of a small business router. A large enterprise router would look very big. I'll show that to you guys in class next time because I didn't show that to the group. And other things like cable modem. And then other things like an example, pineapples and Raspberry Pis. So, we have all kinds of things. You think of the Internet of Things, we have lights, like an example. This light here turns on and off. That is network based. Oh. Okay, well, we'll try this one here. I guess that was not plugged in. See? Here we go. So, lights can be network based. We didn't add that one to the class, but I'm adding that one. Actually, Ubiquiti makes actual fluorescent lights that are Ethernet based. So, these are some of the different things that physically we would use to make things with a network, right? We have cables, routers, switches, PCs, printers, wireless APs, so access points, or APs for access points. And the next thing, let's break it down into the next portion of this, and then let's use the word TCP, which is one of the students brought up, and then the other one is AD for Active Directory. So TCP is the language of how computers talk. That's what we currently use. So let's add another page to this. Okay. So we have TCP. So if you're in 132 or 133, you will learn all about this. So what are some of the different versions that we have? So we have version 4, which is IP4, which is 32 bits. They have different classes. So they have class A, B, C, and D. One of the other things we have the 3 ways we send it is through TCP/UDP/ICMP. So these are the 3 ways we send it or classify data. So like an example, TCP is a thing like Care Bears. I care that you received this information, so I'm going to say 5 words, you're going to nod, and then I'm going to presume you received the message. May or may not understand the message, but you received it. And then UDP would be like streaming, so that would be like an example, like an announcement being broadcast in the school. That would be an example of UDP where you can't respond back to it, you're just listening to it, which is perfectly fine. It doesn't care if you got the message or not. The intercom, the person says what they want to say, and then they're off, right? So, if you cared what the message was, you're going to ask someone else and say, hey, what did they say? That's the purpose. So, like an example, if we're streaming a video, we don't want to watch the video like, here, I'm doing all this stuff, and now we lost some packets, and now we're gonna go backwards and then start forward. Like, that would drive you bonkers. That would drive me bananas every time I'm watching Netflix and lost a couple packets, and then it would reset for a second. It would wind back for a second and play forward because I missed that. Like my arm's swooping past. Who cares, right? So that's the purpose of UDP. Some traffic, that's what it's designed for. And then ICMP is when we started using our administrative tools like ping, traceroute. That's a particular protocol for these administrative tools that we use and we're going to learn. So that's kind of what TCP is and stuff like that. So let's break down what an address looks like. So I'm going to take an example of a class C address, and that is 192.168.0.0/24. And this is how we represent all of us as a group, like in the classroom. So like an example, we get a package from Amazon, right? We all shop on Amazon, right? Everybody in our family, right? How do we know whose package it is for? Because we all have the same address, right, in our household, right? So we do that by attention to the name. So that's the same way this works. So this /24 represents the mask. That's the lazy way of writing it, which I hate writing, so that's why I write it shorthand, but I also write it both. So you learn both because in the real world, you run into people who write it long ways and people write it short ways. And if you don't know the difference, that's going to look bad. So that is how it works. So basically, 32 bits is made up of binary, and if all 8 bits are on, you can get the maximum of 255. That's how we get that. And 255 because it's made up of 32 bits. Each one is 8, so 4 octets. So now I'm going to draw a couple things out. So let's write this all out here real quick. So as an example here, I'm going to write this out. 192.168.0. 192.168.0. 192.168.0, because I'm going to use different colors in a moment. 192.168 and now we're going to use blue. So this is going to represent the computer. So let's say 33. This is going to represent the way out the door. 1 would represent the DHCP server that provided all this stuff to us. And 2 and 3 would basically be our DNS. This would be our DHCP server, and this is our router out the door. So the reason the last set of octets, because this here represents our house, and the last numbers represent our individuals, like our names. So every network has to have these basic things. We have to have a router to get out of the network, because if we're going to be part of part of the internet, we want to be able to surf the web. Well, you have to have a way out the door. Just like think of the routers like a classroom. You know, we have a door that gets us out in the hallway, and that hallway has multiple doors. Think of that as the router, and then we go from one door to the other. We're literally going in from one classroom to another, and think of each classroom as a different network. That makes sense? If not, you know, bring it up in class. And then DHCP, so we can give addresses two ways. One, we can manually write it down and touch each machine, which is crazy. Like an example, my last place we had 3,000 computers. You know how long that would take you to reach out and touch each one? That's crazy. So we have a service that we call DHCP, and then that provides us a means. So how does that work? So basically it's a service that runs. So when your computer boots up, it's like every computer boots up. Because if we static it, if we hard-coded the machine and we literally move from one place to another, like an example, I take my iPad with me. If I take my iPad here when I'm writing to take notes, like the example, I'm taking notes right here on the screen with my iPad, you know, now if I go to Morton, because we're not using the same address scheme, my iPad won't work. Even though I put in the username and password for the wireless to get on, it's not going to work. So we do dynamic stuff, so this way every time we go to a different network, we can get the appropriate address for that network. Well, hopefully that made sense. If not, again, bring it up in class. We can discuss it. We got plenty of time on our hands in this class. We're not. This is not a fast chat line. So we have time to talk. So that's the nice part about the way this class is set up currently. So that's how that works. So those are the main functions. So let's take a look at it and see how it looks in real life. So here we go. I'm going to make this a little bit smaller. And now we're going to type in this command called ipconfig/all. And this will work on any Windows machine. It's perfectly safe. This does not do anything to your machine. This just basically provides you information. So again, if you just click on start, type in CMD, which will take you to the command prompt, which will give you this nice pretty little black little box with text, and you can just type in ipconfig space. So an example in my class, if I write the word with a B like that, that means it's a space, because command line commands are space sensitive, FYI. Because if you're typing commands and you smash them all together, they don't work. That is going to be the frustrating part of this class, is just getting the hang of the switches and stuff. Once you do it, no big deal. So we hit enter, and then here we can see, yes, your information may vary from yours to mine, because I have 2 network cards, a wireless card, virtualization hooked up on here. So I have a lot more network cards than probably you do. So that's okay. And I have VPNs and all these other fun things. So here we go. Here is my wireless card, or here is my network. So by default, the DHCP server provided me the name of my domain. Here is my physical address. So like an example, when we talked in the class, everybody had the first 6 digits were the same, but the last weren't, because this is a physical address that's built into any card or any device that takes an IP address. Has this, and the first 6 represents who is the owner of it. Not you as the owner, but who manufactured the device. So like an example, who manufactured my computer would be these first 6 digits. And then here you can see that I got this address dynamically. Here I've got an IP6 address. Don't worry about it, we're not going to get heavily into that in this class. So here I got my IP address. Here I got my mask showing again 192.168.2. Yes, my example 0 doesn't matter because there is 2 million I believe there's 2 million addresses or address blocks in a Class C. Well, we'll find out on Saturday if you're in my Saturday class. Alright, so here's my way out the door. We call it a default gateway, or some people call it a router, some call it a DG, or some people call it a DGW. They all mean the same. So this is where my router is sitting. In this particular case, in this scenario, mine is at the beginning of the address. In the example, the other one is at the end of the address. And this sometimes, for home users, these will be the same 2 numbers, but in a corporation, they won't be the same numbers because they have dedicated machines that give that information to. Alright, and then DNS. What is DNS? DNS is our phone book. How do we find things? So like an example, the most anybody knew in the class was like 2 phone numbers. But otherwise we used a phone book in our phone to call everybody, right? Because we have more than 2 numbers in our phone book, but we may only know 2 phone numbers. So that is what the purpose of DNS is. And if you like, I will link you up a good video, or I'll play the video on Wednesday. So there we go. That is kind of what we covered in the course so far. And let's see. Oh, I'm no longer sharing my screen because I guess I went to sleep. So let me get that going. There we go. So now one of the things I like to do, and as I get reconnected, I'm expecting a new wireless access point coming in soon. I ordered it, so hopefully that comes soon in the mail. And we're going to go a long ways because it's just easier for me to draw. So in class I did a little, talked about like how do we get out onto the internet, and so I'm going to draw that out, and hopefully this will make some sense for you. And I do not know why my notebook or my iPad is having a problem with wireless today. It seemed to work pretty good during this video. Sorry, I'm sitting a little further back. I'm just trying to make sure I'm getting close to the access point because it's literally right over there. I don't understand why it's having this issue. Alright. Or maybe it's because it's landscaped. I don't know. Alright, so let's try this while it's working. Alright, so we talked about from the PC. So here we go. So we have our PC here. So, and I'm going to just toggle between these colors as I draw. So from there we have the wall jack where we have the little RJ45. And that looks like something like this that we see in the wall. This is what it looks like when it's not in the wall. So from there we'd have our structural cable that would go into a closet. Again, remember when I told you earlier how many distance? So from there we would have a patch panel, and then from there we would have a switch, and then we would have 2 cables that would connect from the wall to the PC. So here's another little tidbit. So this is 90 meters. Again, it's not on the test, just FYI. The structure cable, that's the cable that's in the wall that comes up and goes into the data center. That cable never moves, and then we leave 10 meters for connecting the PC from the switch and from the patch panel to the PC. So that's how that looks. And then from there we would go to another switch using either like fiber optics into another patch panel, and then from there a switch, and then it connected, and then from the switch here we would have a server switch where off of here we would have our DHCP, our DNS1, our DNS2, and we would have our AD. And then as the computer would boot up for the first time, it's going to do a broadcast. It's going to yell and say, hey, I need an IP address. And then from there, it's going to send a packet from here. Let's pick a different color if I can. Alright, well, I guess we're going to go with red. So it's going to come from here, go into the switch, come from the wall jack into the patch panel, to the switch, because the switch is going to say, oh, it's a DHCP request. He's going to forward it on to this master switch, and the master switch is going to send it to the DHCP server. And the DHCP server is going to be like the Godfather. He's going to give you an offer that you can't refuse. In return, you're going to give him your MAC address, which I showed you earlier, and your host name. And that's how it keeps track of how long you can have this address. And then that'll come back, that offer will come back to the machine, so that machine will send that back, and then that PC will acknowledge and say, yes, Godfather, I will take your offer and live with it. And then, and then there we go. That's basically the steps of getting an IP address. And then the machine boots up to the login screen, and that's the next step. So what that computer is going to ask you is, okay, you've got your username and password, you put it in, it sends that information, it goes through the switch, to the switch, now it hits the Active Directory server. The Active Directory is where we centralize and use all our accounts. So like an example, like Blackboard, you use your same email address, read your mail, same email address and password, right? And we use the same username and password to log in like the computers in the library, right? So that is all centrally managed in one spot. That is this AD server here. So this ID server will say, yes, you are authorized, no, you're not authorized, or yes, you're authorized based on time, where you're at, and stuff like that. So you could be authorized to access only certain machines, all the machines on campus. It all depends on how we want, how they set it up. I mean, we could literally say, you can access only these 3 machines, and that's it. You go sit on the 4th machine, you ain't getting in. Even though you have a valid username and password and the valid time to be there. That's how granular we can get with this stuff. So like in some organizations where you're not a student, where you're just randomly walking around, you can only log into like 2 machines. Yours, your laptop, and maybe your co-workers, depending on how their environment is set up. So, I mean, every network is different. There's different reasons that we do this, especially in security. Do we want one person to log in 6 different machines at the same time? No, that would be bad. But do we do it? Well, maybe. Again, those are, different options. So this is some of the things that we talked about, and then that's basically, now once you got the yay, now the computer boots up, or it logs you in, now you can play solitaire, now you can watch your favorite YouTube videos, and all that. And then if we want to go to the internet from this master switch, we are going to add a router, and that would get you out to the internet. That's the fundamentals. So in security, we're looking at physically protecting it, logically protecting it. So, and then in policy-wise protecting it. So that was one of the things we talked about. Essentially, there's three types of IT people. There's people who deal with physical security. IT secure network security people who go and you buy this new firewall and you're like, yes, here's this new firewall. And then you're like, okay, there's the information security person who deals with the risk. And then he says, oh, this router's too risky. You can't use this one. Use this one. Well, that is your job, is being the IT security person. You're like, okay, fine. And then there's the information specialist who deals with risk management and makes a decision. So like an example of risk management is, like, we all make decisions, right? So like an example, you've all made a decision to come on campus and hang out with me on Mondays and Wednesdays. And some of you even made the decision to hang out with me more than that, which is perfectly fine. But that's an example of making a risk, because you felt that it is acceptable level of risk at coming on campus. Again, as you walk in the door, you grab a wipe your keyboard and mouse, your area where you're working down. I will supply you with a wipe. And, you know, now the school is mandating everybody to wear a mask, where last week we weren't half to mandated with a mask. So that's an example of risk. So again, if anybody has any other questions or anything like that, I'll see you guys in class. And again, my office hours are posted. I officially posted them, so I'm also doing them physically and online. So, because I know some of you guys take the bus, and I don't want you to take the bus just to come and see me for 10 minutes, so you can meet me online. And if you you know, want to like literally talk instead of using the computer to talk, we can do that too. You just need to, you know, text me and say, hey, can we talk on the phone? And then I would call you back from my Google Voice, and then we can have a conversation. So again, there's a couple different ways how we can meet. So I just want to make sure, you know, I don't want you guys to come just to talk to me for 5 minutes and take, you know, an hour-long bus to get there. So, you know, so I'm giving you guys some different options and how we can meet on office hours. All right? Cool. Any other questions? Again, for a speedy response, text me. Some of you guys have been doing it. Email me if you want a medium response. All right. I will catch you guys later.